All right, starting lesson 7.3, special right triangles. All right, now there's two special right triangles. There's the 45, 45, 90 and the 30, 60, 90. What does that mean? It means the angle measurements are 45, 45, and 90. And if you have a triangle with those angle measurements, the side lengths have a special relationship. Okay, now if both of these angles are 45 degrees, that means the sides across from them are the same length. So in this case we have x and x. All right, these are both of the legs of the right triangle. Now it doesn't matter which leg you use. If you multiply the length of the leg by the square root of 2, you have the length of the hypotenuse then. All right, so you take the length of the leg, you multiply it by square root of 2, and now you have the length of the hypotenuse. For a 30, 60, 90 triangle, there's a little more you have to pay attention to. All right, here I have a 30-degree angle. That's the 60. And there's my 90. Okay, now everything is based off of the short leg. The short leg is across from the smallest angle, the 30-degree angle, okay? That's our x. And from there, I can figure out the length of the other sides of the triangle. I take the short leg, I multiply it by the square root of 3. And I get the length of the long leg. All right, the long leg is across from the 60-degree angle. To get the hypotenuse, I go back to the short leg. This is the foundation for a 30, 60, 90 triangle for figuring out all the other sides. I take the short leg, I multiply it by 2, and I get the hypotenuse, 2x. Okay? So, to summarize the properties here, if I have the length of the leg, I multiply it by square root of 2, and I get the hypotenuse for 45, 45, 90. If I have the short leg for 30, 60, 90, I multiply it by the square root of 3, and that gives me the long leg. To get the hypotenuse, I multiply it by 2. All right, a lot of students confuse these two. All right, for a 30, 60, 90, it's just 2. For a 45, 45, 90, it's square root of 2. And a couple important notes here. The short leg is opposite to the 30-degree angle, and the long leg is opposite to the 60-degree angle. Just wanted to emphasize that one more time. Okay, so for a 45, 45, 90 triangle, the leg times what is equal to the hypotenuse? That would be the square root of 2. For a 30, 60, 90 triangle, the short leg times what is equal to the long leg? That's the square root of 3. For a 30, 60, 90 triangle, the short leg times what is equal to the hypotenuse? It's just 2. All right, for example 1, let's apply these 45, 45, 90 and 30, 60, 90 properties. For part A, I'm looking at a 45, 45, 90 triangle. All right. The sides opposite of those angles are the same. They're both 5. So what do you do to the leg of a 45, 45, 90 triangle to get the hypotenuse? You multiply it by the square root of 2. And that's equal to the hypotenuse, which in this case is x. So x is equal to 5 square root of 2. Okay, once you know these properties well, for a 45, 45, 90 triangle or a 30, 60, 90 triangle, you could just start figuring out the side lengths super fast without having to apply the Pythagorean theorem. All right, for part B here, the Pythagorean theorem won't work because I have 2 unknown lengths. But if you know your 30, 60, 90 properties, you could figure them out. All right, so across from the 30-degree angle here, this is my short leg. This is my short leg right here. What do you do to the short leg to get the long leg? I take the short leg, I multiply it by the square root of 3. And that's equal to the long leg, which is x. So x is equal to 10 square root of 3. All right. And then now here I have the short leg once again. I go back to that because that's the foundation for figuring out the other side lengths. I take 10 and I multiply it by what to get the hypotenuse? I multiply it by 2. And that's equal to the hypotenuse, which is y. So y is equal to 20. Done. For C, what do I have here? This is 45, this is 90. All right, subtract those angle measurements from 180, and you get 45. Once you do enough of these problems, you'll just see what the angle measurements are right away. Okay, so I have 45 and 45, 90. Across from the 45-degree angles are the legs, and the legs have the same length. So if this is 8, then this is 8. X is equal to 8. Okay. Now, what do you do to the legs, or the leg, of a 45, 45, 90 triangle to get the hypotenuse? You take the leg, you multiply it by square root of 2, and you get the hypotenuse, y. So y is equal to 8 square root of 2. Done. Let's do some more examples. All right, here I have a 45, 45, 90. These are the legs. Multiply them by what? Square root of 2, and you'll obtain the hypotenuse. Done. All right, for the next one, here you have the short leg of a 30, 60, 90. Multiply it by what? Square root of 3, and you get the long leg, x. All right. Take the short leg, multiply it by 2, and you get the hypotenuse, which is y. So y is equal to 16. Done. All right, for the next one, here you have a 45-degree angle. That's 90, so this is also 45. The side lengths across from the 45-degree angles are equal, so x is equal to 3. What do you do to the leg to get the hypotenuse? You multiply by square root of 2. That's what y is equal to. Y is equal to 3 square root of 2. Done. All right, going on to example 2, you're going to have to put forth a little more thought in doing the following problems because they're not as straightforward as the previous examples. Find the value of the variables. Okay, here I have these two side lengths that are the same, so the angles across from them must be the same. If this is a 90-degree angle, these both must be 45. Okay, you could call them both y, and you could do y plus 90 equals 180, and you'll end up finding out that y is equal to 45. Okay, so I have a 45, 45, 90 triangle here. I don't know what the length of the legs is. I know the hypotenuse is 12 square root of 2, though. Now, once you get really good with these problems, you're not going to have to do much math, but we're going to go through it step by step in order to figure out the length of the legs in this case. All right, so what do you do to the leg to get the hypotenuse of a 45, 45, 90? You multiply it by the square root of 2, and that's equal to the hypotenuse, which is 12 square root of 2. Now, to get x by itself, I divide by square root of 2. These cancel, x is equal to 12. That's all there is to it. Done. All right, now for part B, I have a 60, 90, and this would be 30. Just subtract both of the angles from 180. Okay, and I need to figure out what the short leg is because I have the long leg here. So what's the relationship between the short leg and the long leg? I take the short leg, I multiply it by the square root of 3, and that's equal to the long leg, which is what? 5 square root of 3. So I divide by square root of 3 now, and I'm able to solve for x, the short leg. Done. All right, so now to figure out the hypotenuse, I take the short leg, which is 5, I multiply it by 2, and I get the hypotenuse. So y is equal to 10. For C, what do I have here? I have the short leg. What do you do to the short leg? Oh, this is 60 though, sorry. Subtract 30 and 90 from 180 and you get 60. All right, so I have a 30, 60, 90. This is the short leg because it's across from the 30-degree angle. I multiply it by the square root of 3, and that gives me the long leg. Okay, now a lot of students mix these up here. Watch out for this. Just because this has a square root of 3 in it does not mean it's the long leg. This side is across from the 30-degree angle, which makes it the short leg. I multiply the short leg by the square root of 3, to get the long leg. So I end up with 4 times 3. Square root of 3 times square root of 3 is 9, which is 3. Or square root of 9, which is 3. And then I get x is equal to 12. Okay? To get the hypotenuse, I take the short leg, I multiply it by 2, and I get the hypotenuse. So y is equal to 8 square root of 3. Done. All right, let's do some more examples. Getting a fraction to not have a denominator that is a radical is called rationalizing the denominator. Okay, what is this? All right, we're going to see what this is in the following examples. Find the value of the variables. Okay, so here I have both of these sides are the same, so that means the angles across are the same, so they're both going to be 45. Okay. Now, don't always assume that with any triangle. I know since this is a right triangle that these both have to be the same then, and they're going to be 45. Okay, so now I take the leg and I multiply it by what to get the hypotenuse? I multiply it by the square root of 2 and I get the hypotenuse. Now to get x by itself, I divide by square root of 2. Okay, now you should be done at this point. You've isolated x. But typically in mathematics, they don't want the answer stated with a denominator that's a radical, all right, or a square root. A square root is just one type of radical. You're going to learn many more in the future. All right, so now what do? Well, to get rid of the square root in the denominator position, you simply multiply it by itself. But whatever you do to the bottom, you also have to do to the top. So I have 10 square root of 2 over 2. All right, because square root of 2 times square root of 2 is 2. Now I divide 2 into 10, and I get 5 square root of 2. Done. All right, let's do one more example. Here I have 60, 90. This is 30. Okay, this is the short leg, because it's across from the 30-degree angle. This is the long leg. So I take the short leg, I multiply it by the square root of 3, and I obtain the long leg, which is 9. So now I divide by the square root of 3, cancel that out, and now I multiply the denominator by square root of 3, top and bottom, to rationalize the denominator, to get a fraction that doesn't have a radical in the denominator position. So I end up with 9 square root of 3 over 3. Dividing 3 into 9, I get 3 square root of 3. Done. I also need to figure out y now. And I take the short leg, I multiply it by 2, and I get the hypotenuse. So 3 square root of 3 times 2 is equal to the hypotenuse, which is y. So y is equal to 6 square root of 3. Done. All right, example 4. Find the area of the regular triangle. All right, this is where you begin to apply your knowledge of 30, 60, 90 triangles and 45, 45, 90 triangles. All right, so I have this regular triangle here. Regular means that all the sides are the same and all the angles are the same. Okay, so now what do? Well, that's 8, that's 8. Okay, I'm going to split this triangle in half. Actually, before I do that, I want you to understand one thing. What's the measure of all of the angles? Well, it's an equiangular triangle, correct? So that makes all of these angles 60 degrees. All right, you just take 180 and divide by 3 because they're all the same. All right, now I'm going to cut this triangle in half like this so that I end up with a right angle here. And if I do that, this length here is 4. And this angle up here is 30 degrees. Okay? So now let me use a different color to make this stand out. I'm working with this triangle here, this green triangle. Okay? And I need to figure out the height of the triangle. So this is my short leg because it's across from the 30-degree angle. So I take the short leg, I multiply it by the square root of 3, and that gives me the long leg. The long leg is the height in this case. So my height is 4 square root of 3. All right, now, the area formula for a triangle is base times height divided by 2. There's a couple of things you need to be careful with. What is the base of the whole triangle, the whole thing? It's 8. Okay, watch out for that. A lot of students use 4. That was the base of the triangle you were working with in the beginning to figure out the height, but it's not the base of the triangle that you're trying to find the area of. All right, so that's 8 times the height, which is 4 square root of 3, and then I divide by 2. So the area of this triangle here is 8 divided by 2 is 4. 4 times 4 is 16, so 16 square root of 3. And I'll say it's feet squared. Done. All right, for part B, all right, what's going on here? I have an isosceles triangle. All right, what are we going to do here? Well, since it's isosceles, I only could cut it in half going this way. All right, and I know that these angles here are the same, but all of the angles aren't the same. I know that this here is 9, this length. Okay. How am I going to figure out the height? Okay, so this is the height here. All right, it's as if you took the triangle and you tipped it over, since we're working with an isosceles triangle. All right, and you could redraw the figure if that helps you. All right, so what am I going to do? I'm going to use the Pythagorean theorem. My height is my b. So I have 9 squared plus h squared is equal to 15 squared. So I have 81 plus h squared is equal to 225. I subtract 81, and I get what? I get 144. Don't forget the squared. Now I square root both sides, and h is equal to 12. All right, there's something to work with here. Now, here's another thing you could have done that I want to point out. Remember your Pythagorean triples? I could say this is divisible by 3, so I have 3 times 3. This is divisible by 3, so I have 3 times 5. So how do you get the other length? It's going to be 3 times something. Well, this is going to be a 3, 4, 5 triangle. So if you saw that, then that'll make solving the problem much faster. All right, but anyways, I still got the height. It's 12. So the area of the triangle is base times height divided by 2. The base is what? This whole part here, which is 18, times the height, which is 12, and then I divide by 2. So I'm going to divide 12 by 2. I get 6. And 18 times 6 is 108. And this is going to be centimeters squared. All right, for the next example, the altitude, which in other words is the height of an equilateral triangle, is 9 centimeters. Find the length of a side of the triangle. All right. They tell me I have an equilateral triangle, and its height is 9 centimeters. All right, it's equilateral, so that means it's also equiangular, which means all these angle measurements are 60 degrees. And if I focus in on this triangle here, then this is 30 degrees. That's 90. Okay, and this is the short leg. That's x. And this would be, the height would be the long leg. All right, so what do you do to the short leg to get the long leg? I multiply by the square root of 3. And that gives me the long leg. So now I divide by square root of 3. And now I have the short leg. And I'm going to rationalize the denominator. So I have 9 square root of 3 over 3. So then I end up with 3 square root of 3. That's what x is equal to, 3 square root of 3. All right, now that is not the length of a side. You have to be very careful here, because I've seen students do all this work, and then they box this as their answer. Don't do that. This piece here is 3 square root of 3. How do you get the whole thing? Well, you multiply it by 2. So 2 times 3 square root of 3, you could call it y if you like. That's equal to y. You got to double it up. So I end up with 6 square root of 3. That is the length of a side for the equilateral triangle. All right, let's do a couple more examples. We're almost done. Example 5, the perimeter of a square is 28 inches. Find the length of the diagonal. All right, you have a square. What do you know about all the sides of a square? They're all the same. And all the angles are 90. And they want you to find the diagonal of the square. Diagonal. All right, well, if the perimeter is 28 inches, I divide that by 4, and I get the length of all the sides. So 7, 7, and 7. All right, so I'm going to focus in here on one of these triangles. Okay. And what type of triangle is it? Well, I have an isosceles triangle here, and it's a right triangle. So that makes these angles 45, 45. What do you do with the leg of a 45, 45, 90 triangle to get the hypotenuse? You multiply it by the square root of 2. That's all there is to it. You're done. All right. And for B, the diagonal of a square is 6 meters. Find the area of the square. Okay, so I have a square again. The diagonal is 6 meters. They want me to find the area. Okay, well, just like before, I know that these triangles are 45, 45, 90 triangles. This is X. Okay, well, what do you do to the leg to get the hypotenuse? Or in this case, the diagonal. I multiply the leg by square root of 2 to get the hypotenuse, which is the diagonal. Now I divide by square root of 2. All right, and I'll rationalize the denominator here. And I get 6 square root of 2 over 2. X is equal to 3 square root of 2. All right? All right, so to figure out the area, I do base times height or length times width. All the sides are the same, so 3 square root of 2 times 3 square root of 2. I get 3 times 3, which is 9, and I have square root of 2 times square root of 2, which is 2. So the area is equal to 18 meters squared. All right, that's it for the lesson. It all comes down to understanding the 45, 45, 90 triangle properties and the 30, 60, 90 triangle properties. If you understand those really well, then you could just easily go through all these problems. If you have any questions, please make sure to ask. Begin the assignment.